Welcome back to The Explainer. Today we're diving into a genuinely fascinating piece of engineering. We're talking about a massive breakthrough in defense technology that's literally turning heads all over the globe right now. It's India's new LRGR-120. If you're at all curious about how modern tech is completely rewriting the rules of engagement, well, you're absolutely in the right place. Let's get right into it. Just think about the physics of this for a second. What if a rocket could travel over 120 kilometers? That's roughly the drive from New York City to Philadelphia, and strike a target so precisely that it lands within just a few meters of its bullseye. Sounds like science fiction, right? It's kind of like trying to thread a needle while running a marathon. But there's no way around it. That's exactly what the LRGR-120 is doing. It's just a stunning combination of immense range and pinpoint accuracy. So, here's our roadmap for today's explainer. First, we'll officially meet the LRGR-20. Second, we'll look closely at its precision guidance technology. Third, we'll explore the 120-kilometer advantage. Fourth, we'll discuss the concept of Atmanirbhar. And finally, we'll wrap up with the future of precision strikes. All right, Section 1, meet the LRGR-120. What exactly is it? So, LNRGR. That stands for Long-Range Guided Rocket. And that 120? Well, that's simply its very impressive operational range of 120 kilometers. This system was designed by India's Defense Research and Development Organization, commonly known as the DRDO. And their objective here was simple in theory, but incredibly difficult in practice. Give the armed forces the ability to hit high-value targets from vast distances, but without sacrificing even a single inch of accuracy. To put that into perspective, for decades, traditional artillery relied on basic ballistic trajectories. You basically fired, physics took over, and you kind of just crossed your fingers that a strong gust of wind didn't push it completely off course. But guided rockets, they represent a massive technological leap. They actually use active navigation to stay on course mid-flight. This means military commanders can strike critical positions using way less ammunition, and crucially, this is a big deal, they drastically reduce the risk of collateral damage. Moving right along to Section 2, Precision Guidance Technology. How does it hit the target? Accuracy over sheer firepower. Really, that is the defining philosophy of modern warfare. In the past, militaries heavily relied on overwhelming, massive barrages just to make absolutely sure a target was neutralized. But today, that's honestly just outdated. Hitting the exact target with a single, precise strike completely changes the entire outcome of an engagement. Systems like the LRGR-120 are absolute game changers for sure, because they're the tools making the surgical approach a reality. So you might be wondering, how does it actually pull this off in midair? Well, it's essentially a self-driving rocket running a continuous three-step loop. Step 1, the navigation system tracks its position in real time. Step 2, the onboard electronics process that data, instantly calculating if it's drifted off path by even a fraction. And finally, Step 3, the flight controls physically adjust the trajectory. It's literally out there constantly fixing its own math while flying at incredible speeds. That onboard intelligence right there is the whole secret to maintaining such a highly accurate trajectory over those really long distances. That brings us to Section 3, the 120-kilometer advantage. Tactical survivability. 120. Sure, it sounds like just a number, but on a battlefield, 120 kilometers completely alters the entire dynamic for ground forces. Having a strike range this expansive effectively pushes back the boundaries of the front line. It allows military units to project force and engage imminent threats far, far beyond the traditional horizon. The crucial equation we need to look at here is this. Standoff distance equals enhanced survivability. You see, this isn't just about destroying enemy assets. Fundamentally, it's about protecting human operators. Because this rocket can be fired from so far away, the launch units remain heavily insulated from enemy counterfire. So it massively improves the survivability of the crews, all while creating an absolute nightmare scenario for opposing forces. Let's look at the specific threats on the menu here. We're talking about taking out high-value targets. With this system, forces can neutralize command centers, they can blind radar installations, or hit troop concentrations. And here's the real why this matters takeaway for you. They can do all of this without ever requiring manned aircraft to fly into contested, highly dangerous airspace. Basically, you're getting the heavy impact of an airstrike, but entirely from the safety of the ground. Now for Section 4, Atmanirbhar Bharat, a self-reliant defense ecosystem. For decades, the historical norm for India was pretty clear. Rely heavily on foreign imports for advanced military systems. But right now, we are witnessing a massive paradigm shift. Today, through the DRDO and their partnerships with private industry, India is designing, testing and actually building these highly sophisticated platforms entirely at home. The LRGR-120 isn't just a military win. It's honestly a massive flex of indigenous engineering. Think about it. To build a rocket like this, you have to master propulsion systems just to get the distance. You have to master guidance tech and onboard electronics to keep it on path. You need completely flawless software integration. And, of course, you need the advanced manufacturing base to physically build the whole shebang. Mastering all of these elements simultaneously proves without a doubt that India's domestic tech base is maturing at lightning speed. There's a quote directly from our source material that I think perfectly captures the national strategy here. It says, "Every successful test strengthens India's indigenous defense ecosystem and reduces dependence on external sources." This rocket is quite literally the physical embodiment of Atmanirbhar Bharat, which translates to a self-reliant India. At the end of the day, it's all about securing those critical supply chains and maintaining complete sovereignty over advanced defense technologies. And finally, Section 5, Future of Precision Strikes. Building the foundation. It's absolutely vital to understand that the LRGR-120 isn't just some isolated weapon system, not at all. It's actually a technological foundation. It reflects a much broader, ongoing evolution in India's defense programs. The success we're seeing with this rocket's guidance, its propulsion, and its software, all of that is going to feed directly into the DNA of the next generation of precision-guided platforms. So, as global threats continue to evolve and warfare becomes almost purely technology-driven, it leaves us with one big question. What indigenous system will India develop next? The LRGR-120 has already proven that the capability and the strategic vision are securely in place. The foundation they're building today will undoubtedly lead to even more fascinating breakthroughs tomorrow. Thanks so much for joining me for this explainer. Keep your eyes on this space because I promise you this technology is moving incredibly fast.